So this project is to take an existing weed whacker we have, Black & Decker, and add some wheels that stick out the back that let you use it like a lawnmower. We have a very tiny lawn section, and a full-size lawnmower doesn't really make sense. So something that'll clamp on here, that'll extend out with two wheels either side, that's the goal. So I found a piece of scrap. I'm just going to face it off. Bored out to an inch, just relieving. So far we have used a 1/2 inch end mill to put some flats for the 1/4-20 screws to go through. We've milled a flat to remove some excess material and to make it so that I can mill the flat on the other side without having any issues of being exactly opposite, and I'm doing that for cosmetic purposes. So next I'm going to drill and tap. I'm going to drill for the tap size and go all the way through on both sides, and then we will come back and mill the flat on the other side. So we're going to through drill 1/4-20 or 1/4-20 taps, and we will come back later and body drill the top half after I've cut it in half. I'm not sure if I can power tap all the way through, but we're going to try and power tap at least part way. Slow it down so we have better control. Now we're milling the flat for the weld. I went down 50 thousandths and go down another 50. What I need is a total of 1 inch wide. You can go down a little further. So we'll just take another 50 and make it even 150. Actually, let's do, make it an even 1/8. We'll do 125. So we're using the slitting saw to cut this in half. Sorry, lost the first part of this. Note to self, if I'd flipped the teeth around, so flip the saw blade upside down, then the chips would be going back instead of forward. Would have been smart. There we go. Okay. Flip it around and go again. Finishing pass. we're done. So far on the wheel part of this project, I have created the mounting bracket on the vertical column. Now I'm going to cut this to length. It's not cut to length yet. I need to make a circular part that is going to have a vertical shaft to adjust the height on the wheels that'll be running on this. I've got to do the vertical shaft itself, and then the horizontal shaft that the wheels will be mounted onto is going to need on the end, the wheels are going to screw in, so I've got to make these threaded inserts for the horizontal shaft in some square stock. But for now, we're going to go for a 1-inch diameter hole in this guy, which will be the locking vertical adjustment piece. So we've just drilled through to just under 1/2 inch, stepping up to remove more material so the boring will be easier. 3/4. There's 75 thousandths. Another 75 thousandths pass. So on this pass, we're going to get really close, within a couple thousandths. So the material that's going in the middle is 1/1000th over 1 inch, and we're about 2.5 thousandths under. So let's do 3 thousandths, let's do 4 thousandths, and it'll give us a tiny bit of slot. I got a hairball coming out the other side. We just buffed the inside of that nicely. Finish is good though, very smooth. I'm annoyed that it did that, but just can't have everything. So here's a piece of material, and I haven't chamfered it yet. That's a really good fit, just 1/1000th to 2 slot, which is what I want. I'm going to end up taking this. This is the vertical shaft. I'm going to end up cutting a flat down the length of it, and then I'm going to take some of this material and I'm going to make a little insert that presses against that flat with a set screw going through the outside. So that mostly finishes this piece, and we will move on to the next piece. So this guy is the horizontal shaft that the wheels will mount on either side, and now I need to make some inserts that will go in the end that I can tap and thread for 3/8/16, which is what the wheels will go on. So this is 750, this is 740, so I need to turn this down just a little bit, and then I'm going to leave a bit of a ridge, and I'm going to weld it on the end, one on each side. So I need to make 2 of them. So that's my next plan of action. So I was mistaken, it's actually 797.797. We need it down to about 0.740. So we want to go in about 1/2 inch. 3/4. Alright, we'll come back and do finish length after. Let me give a measure here. So we're looking for 740. I want it to be a fairly good fit because that'll make it sturdier. So 760.5. And this stuff's extruded, so it's not terribly accurate. Okay, you know, that's going to be a good tight fit. That's exactly what we want. A little bit of an interference fit's not going to be a problem. That'll actually help support it. So we're going to go with that. So we're going to drill and tap for 3/8/16. and then make another one. Just going to use a center drill to clean up this side just a little bit. That's it. Okay, let's part this sucker. I'll make both of these, then I'll turn them around and tap them at the end. Alrighty, one down, one to go. So now we flipped it around. I'm just going to quickly deburr this side, countersink it a little bit with a center drill. And then we're going to come back and tap it. But first I'm going to do the same thing to the other one. It's a nice fit. Ooh, it's even snug. Excellent. So one more and we'll be done with this part. So we're down to the last couple bits here in the lathe. This next thing I've got to do, this is the 1-inch shaft that is the wheels we mount on either side of this guy, and this shaft is going to go through this. So what I'm going to do is I'm going to drill a 1/2-inch hole all the way through this part. This needs to be turned down to a 1/2 inch. I'm going to make it stick a little bit proud. I'm going to weld both sides so that this will be stiff. This will be the height adjuster. This is the height adjuster for the wheels. So let's do that. Let's see where we're at now. If I cared, I'd use a mic, but this really is not particular. So 0.519. So let's take 19. Alright, let's go and do the final dimension here. Done. So now when I drill a 1/2 inch hole through this will stand a little proud. I'll weld it on this side and the other side both. So this guy right here is going to be welded to the cross beam that is attached to the arm of the weed whacker, and the height adjust of the wheels will be done here. So this guy is going to get a flat put in. I'm going to take it down 1/4 inch of material out of the round. So what this piece is going to be is it's going to be a pressure plate. So first I'm going to take this guy down to 1 inch in diameter, about 1 inch back, so it'll fit all the way through here. And it's going to be larger. I'm going to have a larger diameter edge because that'll be the lip that'll prevent it from falling through. And then I'm going to have to cut it off with a saw to get just this part of the profile that's going to slide down inside here. again, hopefully it'll be clearer when I start to assemble the whole thing. So first we're going to face this guy as usual, just clean up the face. I'm using a CCM-MT insert with a Kennametal holder that I just got, A-bomb style. He seems to like them, so I'm going to give him a shot. Just going to see how this works out. I'm going to do without coolant, so it's probably going to get a little warm. Let's start with facing it. This is 303 stainless, by the way. And we are at 440 RPM. Chip breaker's working on the inside at a slower velocity. Kind of interesting. So the linear velocity towards the center, at the very center, is 0. At the outside edge, it's much greater. It's interesting the chip breaker started to engage sort of halfway across. All right. Do another 50. First step, we're not going to very carefully drill, well, we're going to drill and ream because I'd like it to be somewhat tight. The hole for this piece to mount in, this is the vertical height adjusting rod. Alrighty. So here's test fit with the vertical adjustment shaft, and that's a really nice fit. It's really tight, just 1/1000 and a half extra slop in it, so that the shaft on the edges of the hole will support it as well as the weld. So if the weld flexes just a little bit, those edges will also help support it and add strength. So that's my thinking. So next we're going to mill a tiny flat in the adjustment flange. This is going to be drilled and tapped for 3/8/16 thumb tightening device here that'll press against the pressure plate, which is this guy that I've yet to finish. So we're just going to make a little flat just to make it look pretty. Just come up a little bit here. Perfect. All right, so we're drilling for the tap hole now. And we're going to try this again without lube, only because the lube is going to make a mess when I try and weld this. And I can clean it, just kind of challenging, so. Okay, well I should have just accepted that I'm going to need the lube because I don't think there's any way I'm going to be able to tap it without lube. So we're going to add the lube and then just be careful to clean it. Alright. Alright, tapped away. I'm going to relieve this side a little bit to clean up that burr. Then we'll flip it over and machine a flat for the other side. Before we go, here's the knob. It's going to go in here. It's kind of hard to start, but once you do, it's in there. Alright, so we're going to flip it over and mill a flat, machine a flat. So this next part is not an extreme precision bit. We're just looking for a little bit over an inch a flat on here, so we need to go down, I don't know, it's like a little, like a eighth of an inch, 125 thousandths or so. So that's what we're gonna do. It's not, again, not a precision operation. It's just to create a flat for the weld to bind to. So I get a rough idea how deep I'm going. All right. So now we got a little less than a half-inch swath. So we're gonna go up 50 thousandths, which will probably require me to go over, which is, yeah, there you go. I want to make sure the cutter goes off the end. So you can see we're still a little under, so we got to go deeper. So we'll do another 50. There we go, it's around just about an inch. If I go a little bit larger, it'll make it easier to catch the edge. I think I'll do that. Let's go a little bit more. I think I'll do that 25 I was talking about. And then we'll be done. Speed this up. That's better. Now we're a little over an inch. 125 thousandths is right on what I'm looking for. Okay, this piece is done. So now we're going to put a 1/4 inch flat all the way down. The length of this stopping, I don't know, maybe half an inch from the bottom. That's not really critical. That's mostly for so this part is finished till I weld it on. Alright, so I'm not really sure how this is going to work. As usual, I have very little experience with slitting saws. I think historically I've been nothing but impressed at how well they work. So we will try 120 RPM, 140. Let's do 140, we'll add some lube, and we will take very slow cuts. I have to go in a little over an inch, so I don't know, let's see how this works. I don't know if I'm touching yet. Alright, so let's call this X0. So let's try 25 thousandths. This is cutting stainless steel now. It really does seem to cut okay. Now we're actually cutting into the main part where I want to, because I want to create a lip that'll hold this in place. So now I've reduced my passes to 50 thousandths. Alright, so I'm just showing you the beginning of this, but I am going to part this guy off the same way as I cut the other piece and just do lots of successive 75 thousandths passes until I'm through. I didn't get this in perfectly square to the jaws, so the other side's already cut through. So when this side goes through, then the part will come free. Like that. Here's the part. Here's the part, so I need to clean it. Alright, so here's where we are before the welding. This guy gets put in here and welded. Both sides. This guy gets welded onto a piece similar to this that's mounted to the weed whacker already, like that. So one of these gets put in each end because those are the threaded inserts that will hold the wheels, and we should be done. And I can show you this thing assembled. Alright, so here's the assembly. I painted it a little bit. I thought it would look better. My wife appreciates that. So, wheels go on pretty simply. Then, this part goes in here, and it's a little larger than halfway, so it can't actually lean back and forward, so that's actually a strong feature. There is the bushing to push against, or the I guess bushing really is a good name for it. And this thread, for whatever reason, it's really hard to get started, but once you get started, it's no problem. So here we are. Now all I have to go over is clamp this on, and we'll be good to go. So here's the final result. I realized after I put this together, I forgot to trim this arm down. I wanted it a little bit closer. I can still make adjustments to it. It'll take a little bit of extra welding and some repainting, but it actually gives it a fair amount of stability having it back farther, so it might actually work out all right. We'll have to try it and find out, and if it doesn't, then I can cut it and make it shorter, but in the meantime, we'll give it a shot. Right now, it gives really good stability to it, so it's actually pretty easy to keep this at a fixed length. So we're going to try it, see how it works. So now that it's battle tested, some thoughts. First of all, if you have really low grass with a very flat terrain, these wheels are fine. But if you have deep grass and or deep terrain, you need much bigger wheels. So there's the first thing. Lighter would be better. The aluminum's a good choice. Maybe plastic wheels, if you can find large plastic wheels, say 6-8 inch diameter instead of these 3.5 4 inch diameter wheels. I had these on hand, so it's why I use them. The deep bar actually works in your favor. It helps keep it stabilized. So I find that what I end up doing is I use this as still as a weed whacker, sort of lifting it up, but the back wheels set my level as you're swinging it around. It's kind of weird. So there might be a different variation that might work even better. I got to play around. But this is my first thought and first take. It worked okay. I have really ruddy grass back here, so it's not level at all. So the wheels would dip and catch, so that's a problem. But the rest of the garden, it worked pretty well. Where it was flat, where we worked to make it a little bit flatter, it worked reasonably well. So there's my first thoughts, and hope to see you soon. Talk to you next time.